Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting my major presentation, which is the erosion soil control plan. I am Muhammad Adam bin Azman. I am from group 7. So this is the checklist that I will be presenting to you. The first one is the introduction. The second one is the runoff management BMPS, which is the temporary effluent design. The third one is the erosion and sediment control. The fourth one is the sediment basin, and the last one is the other BMPS. So as an introduction, soil erosion is defined as the wearing of land due to wind, raindrops, water, or gravity. Erosion causes soil particles to be separated and transported by the soil of erosion from their location of origin. The phenomenon in which the dislodged soil particles are transported to a new location and deposited on a land surface or bed of watercourse is called sedimentation. Construction involves a large number of intentional and unintentional earth movements. This movement usually leads to soil erosion, which affects the site and the natural area around it. So this is our concern. The first one is the runoff in this project area will be managed by using a temporary earth drain, and the sedimentation will be minimized and controlled by a mitigation plan such as sediment trap, silt fence, and sediment basin. So the next one is the Manual Saliran Mesra Alam MASMA second edition, published by the Department of Irrigation and Drainage Malaysia, is used as the guideline of the erosion and sediment control plan designed for this project. So our concern is that we need to use these guidelines to tackle these erosion problems. So our main objective is, the first one is to provide a minimum standard procedure as a platform for comprehensive erosion and sediment control plan ESCP. So the second one is to follow the specification and requirements stated so that the construction can be carried out in such a manner with minimum land, water quality and environmental degradation. The third objective is to manage and control the erosion and sediment processes in construction and development sites. So the second one is the runoff management BMS temporary earth drain design. So as an introduction, a temporary earth drain is used to divert and channel runoff to sediment control facilities such as silt trap or sediment basin to reduce the potential for erosion and off-site sedimentation. Temporary earth drain shall be constructed to channel surface runoff before the starting of land clearing in the project. In this project, temporary earth drain will be provided within the boundary of the project site. The temporary drain network will be used to collect runoff from the disturbed areas so that it does not run across disturbed and unstable areas. So the objective is, the temporary drainage will curb silt water from the construction site and channel it into the silt trap to prevent it from directly flowing into the nearby river. So the maintenance of temporary drainage should be carried out, such as inspection weekly and after each rain. The accumulated sediment that is built upon the temporary earth drain should be removed to minimize the restriction of its flow capacity across disturbed and unstable areas. So for the design criteria, there are two main points, which is the first one is to able to drain surface and subsurface water away from the project site and dissipate it in a way that prevents excessive collection of water in unstable areas and subsequent downstream erosion. The second criteria is the temporary earth drainage and sediment basin are able to withstand the peak discharge on the site. So there are several factors that affecting this design criteria. The first one is the determination of the average recurrence interval, ARI. The second one is the average rainfall intensity, which is denoted as I, time of concentration TC, runoff coefficient C, catchment area. Later I will show to you. The last one is the estimation of peak discharge QP, which is the most essential in designing this temporary earth drain. So the first one is the ARI. The ARI can approximately estimated as a probability or percent chance of occurring in any given year. The early construction work of a work is assumed to be completed within 2 years. Therefore, in our IDP1 project, we will be using the ARI of 2 years, which is sufficient for this project. So the average rainfall intensity the average rainfall intensity can be estimated by using empirical equation. So basically, we calculated the value of I by using this formula. So I is the average rainfall intensity, T is the average occurrence interval, ARI, D, the storm duration, time of concentration, and the last one is the fitting constant dependent on the rain gauge location. So basically, we use pusat camp perkandanas as our rain gauge location. So the TC is a critical component in some analysis method for calculating peak discharge from an area. The peak discharge occurs when all segments of the drainage area are contributing to the runoff from the site. Few factors affect the time of concentration, such as surface roughness, channel shape, and slope. So basically, the TC is the most essential calculation in determining on how we can design the temporary of drain. So the runoff coefficient, so basically we will be using the 0.50, which is the runoff coefficient 0.5 minus system. So basically this is our catchment area design. We will be dividing it into 4 sub area, 4 zone, and inside the zone we divided it into several sub area. So the last one is the QP. This is the most frequently used technique for peak discharge estimation and expressed as QP equals to CIA over 360. So the assumption of rational method is the peak flow occurs when the entire catchment is contributing to the flow. The rainfall intensity is the uniform over the entire catchment area. The rainfall intensity is uniform over a time duration equal to the time of concentration TC. So this is how we calculate the Q design, design of open channel using Manning's formula reference. So the next part is the erosion and sediment control. So as an introduction, soil erosion is the separation of soil from its original place and transportation to a new area due to wind, water in motion, or the beating action of raindrops. This soil top layer is constantly exposed to the acts of water and wind, which dislodge and transfer the top layer from one location to another. It takes ages to build a 1-inch layer of soil, yet it only takes a few years for it to be eroded away. So basically, the movement of the soil from its origin. So the sediment control BMPS. The function of the sediment control system is to create conditions for sedimentation where the sediment or soil particle in suspension is allowed to settle. Silt basin or wet sediment basin are hydraulic controls that function by modifying runoff hydrograph and slowing down water velocities, and this allows for the deposition of suspended particles by gravity. So the first part, the first subtopic for this part is the soil loss estimation, the universal soil loss equation, USLE. So it is basically a semi-empirical equation used to assess soil losses under different cropping system and management practices. This equation produces the annual soil loss of a site, and hence is very useful in assessing erosion risk to quantify on how it changes throughout the course of development. So this is the soil loss and the sediment yield parameter. The first one is the rainfall erosivity factor R, soil erodibility factor K, LS factor, cover and management factor C, and the lastly is the conservation practice factor P. So the first one is the erosivity factor R. So the rainfall erosivity factor R is determined based on the ISO erodent maps, which are generated using the geographical information system. So basically our site location is Ulu Tiram, Johor. The range is between 14,000 to 15,000. For evaluation purpose, the upper limit of the range is used. So basically we use the R factor is equals to 15,000. So in this project, my respective Dr. Tirmizi have given our soil erodibility factor K. So the LS factor, we use the calculation method. So as you can see, this is the formula for the LS factor. So the cover and management factor, we choose the 100% cover for the undisturbed existing condition, which is 0.03, and the seed factor for disturbed uncontrolled condition, maknanya during earthwork, is 1.0, and the lastly is the seed factor for disturbed controlled condition after finishing the earthwork. So the next one is the conservation practice factor, which is the P value. So the first one is the value of 1.0, so the P factor for existing and uncontrolled condition. The second one is the value of 0.50, whereby it is the P factor for controlled condition. So the next subtopic is the sediment yield estimation, MUSLE. So sediment yield estimation is used to predict the amount of sediment for sizing and maintenance of sediment control BMPS. The estimated amount of sediment storage volume is used in sediment basin or trap design in the project. So this is the formula. So the next one is the next checklist is the sediment basin. So as an introduction, sediment basin are suitable for nearly all types of construction project. This is a temporary measure with a design life of 12 to 18 months, and it will be maintained until the site area is permanently protected against erosion or a permanent detention basin or water quality control structure is constructed. A sediment basin usually consists of an impoundment, a dam, a riser pipe outlet, and an emergency spillway. The size of the structure will depend upon the location, size of the drainage area, soil type, land use, rainfall amount, and any unique site condition favorable to producing high runoff volume velocity or sediment. So basically this is the design criteria. As you can see, there are several. The first one is the runoff quantity design, runoff quality design, runoff control, flood protection, minimum contributing area, storage volume, basin dimension, embankment, erosion protection, sediment trapping, and last but not least is the maintenance frequency. The next one is the other BMPs, which is our last part. So the first one is the access route. To make note, it is alright of its ways of access road shall be shown on the ESCP, and it shall be responsibility of the developer to ensure that all vehicle traffic stays within the designated right of ways. All vehicle movement on access road shall be kept to a minimum with other areas of limits to traffic. Unpaved road shall be sprayed with water to reduce dust pollution during dry periods. All movement of vehicles over unpaved area should be kept to a minimum. Access road to the site shall be paved for at least 10 meters into the site from any existing paved roads. Washing bays are also provided to remove excessive sediment from outbound vehicle at all site access points. So the next BMP is the seat fence. So basically, it is the most common perimeter control for small site. It is a seat fence. Seat fence are temporary barrier of woven geotextile fabric used to intercept runoff, reduce its velocity, and impound sediment-laden runoff from small areas of disturbed soil. Silt fence should be used along the perimeter of the sites, downslope sites to trap sediment, but should only be used to intercept sheet flow. Do not use them as velocity checks in channel or place them where they will intercept concentrated flow. So a properly constructed silt fence may be all that is required for sediment control on a property managed flat building site. So the next BMP is the wash bays. The purpose of wash bay or vehicle washing system may not be restricted to just sediment control, but can include dust, pollution, and seat control. The primary function of the wash bay or vehicle washing system may be different on construction sites as opposed to the landfill or in sites. The critical design parameter is either the length of the wash bay or the contact time of the vehicle washing system. For example, the jet spray units. Wash bays are primarily used on long-term construction sites and sites containing very clayey soils. So the last BMP is the stockpile. So soil stockpile is formed with soil excavated to provide proper building elevation. Stockpile used to keep the excess soil after cut and fill process. The excess soil either sell to others or used for constructing the slope. stockpile required to be localized minimum 20 meter away from any water course nearby. So any drainage, basically we need to design the stockpile where the stockpile is 20 meter minimum away from the any drainage, and less the surrounding stockpile sufficient drainage network to drain must be provided and channel to sediment trap for sediment control. So that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.